The night sky has long been viewed as a doorway into the unknown. As people throughout history have gazed into the depths of the universe, they have made connections to the afterlife, infinity, and God. One question that led to many of these judgments was, where did all of this come from? Many early cultures may have been satisfied with answers like, there are infinite stars, which have always existed and will always exist. However, one day in the late 1700s, a man named Heinrich Wilhelm Olbers found a piece to the puzzle that contradicted the idea of a static universe. He argued that if there were infinite stars within an infinite space, after a period of time the light from stars in every direction would reach us. In 1848, Edgar Allan Poe contradicted this idea between infinity of the universe and its eternal nature. He argued in a thought experiment of sorts that the night could be dark in an infinite universe if the age of the universe was limited. This was so because it would take time for light to reach us from different stars. These concepts suggested that the universe, the very fabric of space-time, could grow, and teased at the notion that it might even be able to shrink. The growing and shrinking of the universe were attributed to three main forces that guide the universe outward and pull it inward. These forces can be represented on a balloon model where the surface of the balloon represents the universe, and the outside and inside of the balloon, where the air is, have no derivable meaning whatsoever. The force that called for contraction was gravity. Like the elastic of a balloon is naturally inclined to deflate a balloon, matter calls to its counterparts, pulling space together. There is some matter that we can't observe in the universe, except for by its effect on its surroundings. We call this gravitational contraction that is unaccountable for dark matter. The force that causes expansion was dubbed dark energy. Dark energy is a force that is unaccounted for by any visible material actor, hence the word dark. On our balloon model, dark energy looks like a person blowing the balloon up, forcing the universe's expansion to accelerate at a definable rate. If we were to mark off the places where the galaxies belong in our little balloon model, we would see that things are moving away from one another faster the further out they are. The final force is from the original burst of the Big Bang. This force doesn't make matter accelerate away from one another, but rather it has them move at a constant rate from their counterparts. This type of force is the equivalent of blowing up a balloon with one breath of air. In time, the balloon would actually deflate because the gravity in the elastic would dominate the initial boom. With the advent of diverse and varying theories of expansion, scientists now have the opportunity to pick their favorite theory and demand that others accept that it's true. We'll now fade out by showing you what some different basic models look like.